Alright, predicting products. So we'll just start by doing some examples here. The first one I'm going to write out like it would be on a worksheet. The rest of them I'll shorten a little bit. So let's say if the strong acid HNO3 is mixed with water, what will, we kind of started this question earlier, what will the chemical equation look like? And this is basically like the equations you had on yesterday's worksheet. Now you just have to make them yourself. So you know the reactant is going to be HNO3. That's what we're going to start with. And then the question is, what's the rest of it going to be? So we'll start with that. HNO3. Now, I tell you in the problem that this is a strong acid. So actually I wrote strong again. Strong. Just going to correct me. So since it's strong, what does that tell you?
One way.
Arrow's going to point one way. That's the first thing I'm going to do. Point the arrow one way. And I'm mixing it in water, so I'm going to put H2O on top of the arrow. You forget that. That's not a big deal. And then what are the products going to be?
H.
Right. It's an acid, so it has to be hydrogen, H+, right? And then what's left?
HNO. Or N. Yeah, HNO. H1. Okay, no. NO.
Yes. NO3. Like nitrate is what's left.
Is it negative or positive?
It is going to be negative, because this one's positive, so this has to be negative.
He goes actually.
Yeah, so we guys out there?
Yeah, he's always weird to me. He goes. Okay.
Alright, so there we go. The hydrogen comes off by itself because this is an acid, and so whatever's left of this thing, the NO3 and the extra electron, go over here. Right? Let's do another one. We'll do another strong acid. Let's do H2SO4. So this is sulfuric acid. Alright, so again the arrow has to point one direction because it's strong. Right?
Every time you say one direction, it makes me smile inside.
Everyone else in the room can see it. Everyone else but you. Baby, you light up my world like nobody else. The way that you flip your head.
We're going to, for today's lesson, to make everything simple, in any case, we're always going to assume just one hydrogen ionizes. So it's going to be H+, and we're going to assume the other hydrogen just stays with the rest of it. So the anion is going to be HSO4. Now, you know, if you really care, there is a second reaction that happens, don't write this down, where the other hydrogen is given off, but this is, like this second part is a weak acid, right? So it dumps off the other hydrogen, but this only happens to a few of the particles. So the other hydrogen can be given off, especially if you mix this with a base, but it isn't always, so you don't have to worry about that. So for today, it'll just be one hydrogen is given off. All right, let's do a weak acid. So, weak acid. It's weird out there. Weak acid. Let's
Wait, it's supposed to be over it?
no, let's make a new one.
Oh, okay.
Sorry.
Sorry. I wasn't here for like 2 days. I don't know what's going on.
No. So now we're going to do another one. I can't think of a weak acid. What's a good example? I'm looking at you guys think you're going to tell me. Let's do,
C2H4O10.
I was going to do that one, and then I did that yesterday, so I was like, I don't want to do the same one again. Let's do phosphoric acid. Okay, so I told you it's weak, so what does that tell us?
Arrow goes both ways.
Arrow points both ways. And again, we're just going to assume one hydrogen ionizes, so we get our one H plus, and then the rest of it will have dihydrogen phosphate left over. What's up?
It's the same thing.
Oh no. OMG.
You realize what? Yeah, why? Did you say something?
I don't know. I'm trying to remember what I said.
Alright, any questions so far? We know why we got the hydrogen, right? Because it's an acid. You know, whatever's left from here after we subtract one hydrogen, that's what the rest of this stuff is. Alright, let's do a base. Let's do a weak base. Let's do barium hydroxide. I know I'm changing my rules here, but for the bases, I want you to assume that all the hydroxides go away. So it's weak, right? So arrows point both ways.
Why do H2O on the arrow?
Because this reaction happens in water. Now, water's not being used up, water's not being made, but it's in water, so I put it above the
You
arrow.
always write that?
If I write, I mean, you don't always have to, and these ones are all going to be like that.
So
You don't have to, like if you didn't write it, it wouldn't be completely incorrect. It's just if you want to let somebody know, hey, this reaction's happening in water. That's not a big deal.
so we take out OH, right?
Yeah, so both of the OHs are going to go away. So we're going to put OH here,
Why?
just because I said so.
Oh.
And for all the bases, you're going to do it that way. You're just going to assume all the OHs go away. And we're not going to balance it and put a 2 here, I don't care right now. But the barium is going to be here, and that's obviously going to have a +2 charge. If you want to balance it, you can balance it if it makes you happy. So, we good with that?
I think that just confused me.
What confused you?
Yeah. Because I don't like this whole business that because you said so. I need an explanation to balance it.
Balance it. Here, you want to see it? Alright, fine. Take the 2 out. I mean, if you want to put the 2, put the 2. If you don't want the 2, leave the 2 out. I do want you to write the charge for both of them, right? And if this has 2 hydroxides with it, obviously it must have a +2 charge, right? Alright, should we do another base?
Yeah.
Let's do a strong base. Are you guys upset about that?
Yeah, you should have been here yesterday. I was, but then I got it.
Alright, strong base. So, what am I writing?
You're gonna write a one-way arrow, and then hold on, let me write something else. Then you're gonna write plus OH out on the side, negative, and then you're gonna write NA, and you're gonna put H2O on top of the arrow.
Wonderful.
That's what I'm doing.
Right. Sodium plus.
Why?
You have to put that?
You have that?
Yeah, of course. If this is negative, then this has to be
If
positive,
you
right?
put a negative above it, it's obviously positive. So why do you have to like put it?
What do you mean?
Like, I know sometimes like,
What's she saying?
do you have to put the positive next to the element? Like you kind of know that
Why do you know?
because that side's negative and that side has to be positive because it has to balance each other out.
Yeah, it's still proper though. You should write it. Yeah. Alright, should we do one more?
So,
We're good?
no, we're
Okay.
good.
Alright. Okay, let's stop. Oh, thank you.
Yeah, I know.